We're going to take a look at wind-water type of linear system problems. These are the type of problems where you have something moving with and against some sort of current. In this case, an air current with a plane. One way the current will be slowing it down, the other way it'll be speeding up the object. So we're working with distance and speed type questions. In this situation, we have a plane flying 1,200 kilometers from city A to city B with a headwind in 4 hours. So that means that in that headwind, it's getting slowed down, it's pushing against its head and slowing it down. And then on the return trip, there's a tailwind taking only 3 hours. So it's being pushed faster by the tailwind. We want to know how fast does the plane travel in still air, and then what the wind speed is in the case. So we're going to use our variation on the speed, distance, time equations, which is D equals S times T. So distance is speed times time. And we can create two equations. Our variables are going to be this plane P for the plane speed, and W for the wind speed. So those are the two variables we're going to work with. And then our two equations are going to be based off of the distance time formula here. So distance of 1,200 kilometers. And then the speed, in the first case, the headwind is going to be slowing down our speed. So we're going to subtract it from the plane's speed times the time, which is 4 hours. And in the second case, the wind speed is going to increase the overall speed. So we're going to add those, and it's only going to take us 3 hours. So now we have our two equations to work with here, and we can just expand these out is an option here. So let's expand these out, equation 1, equation 2. We'll just multiply both values inside the brackets by the 4 and then subsequently by the 3. So 1,200 equals 4p minus 4w. And in the equation 2, we have 1,200 equals 3p plus 3w. And now that we have two equations, we can use either substitution or elimination to solve this. I'm going to use a substitution method for this one, just for an example. So first, we're going to rearrange equation 1 for P. So we're going to take this first equation here, 1,200 equals 4P minus 4W. And we're going to get P isolated, so we're going to move the 4W over. We get 1,200 plus 4W equals 4P. Divide both sides by 4. And now remember that we can take this 4 on the divisor and we can break it over the two pieces. So 1,200 over 4 plus 4 over 4W equals P. 1,200 divided by 4 will give us 300. And then 4 over 4 is 1, or just plus W. Now that we've rearranged our equation, P is equal to 300 plus W, we can sub that into the other. So since this was equation 1, we'll use equation 2 here and have that subbed in. Sub into equation number 2. And so we have 1,200 equals 3 times, and this is our P here, 300 plus W plus the 3W. So there's our original equation. We've just substituted the 300 plus W in for P. We'll expand that out and then simplify. So we have 900 plus 3W from the expansion, those two multiplications, and there's still that 3W at the end. This 900 can get moved over and subtracted. 1,200 minus 900 equals, and 3W plus 3W is 6W. This leaves us with 300 equals 6W. We divide both sides by 6. And we result with the wind speed being 50. So the wind speed is 50 kilometers an hour. And then we can take that value of 50W and sub that into one of the equations. I'm going to pick this variation over here because the plane speed is just 300 plus the wind speed. So sub into 1, and we have 300 plus 50 equals P, or 350 is our plane speed. So the plane travels at 350 km per h, and the wind is traveling at 50 km per h. 50 kilometers an hour for the wind, 350 for the plane.